Okay, so we have a few questions left. So in this one, we have a probability distribution table given. We don't exactly know yet if it's a probability distribution or not. We'll test it. So what we'll do is I will copy this table onto Excel, the x's and the probabilities. In fact, I've done that here. So you can tell the values here, the probability. So if these probabilities add up to a 1, so I can do auto sum. They do add up to 1, so it is a probability distribution. So we can, since we have the x and the p of x, we can actually find the expected value easily, and that will be equal to the mean. So here you can multiply each row, so the x and its probability, and drop this down, and the sum of these would give us the expected value. So this is the expected value, which is also the mean. So you can type that into this box. So again, you may have a different table. Make sure you put the numbers right and do the calculations and find the mean. So the standard deviation is a little bit more tricky, and it's more convoluted to calculate, but it's not really different. So here, for the standard deviation, you would actually subtract the mean, this one, from each of the x values. So that's what I'll do. So this one minus the mean, and if you put a $sign here, you don't have to write it every time, and you can bring this down here. So that's, see, each of these x values subtracted from this calculated mean, and then you would take their squares, so this to the power 2, same thing with all of them. So we took the square of each one, pay attention to the formula here, and then we would multiply each squared difference of x and mean by the probability. So this would be equal to this multiplied by the probability, and you would bring that down. And then if you just add these up automatically, and then finally you take the square root of this value, so that will be your standard deviation. Okay, so almost done. In this question, we have a jet for 9 passengers, and you're booking 11 passengers. Is it a good idea or not? And this is the probability of someone not showing up. So this is another binomial distribution, binomial probability question. It would be a good idea if you have 9 or less passengers show up. It would be a bad idea if you have more than 9 passengers show up. So if you have 10 people showing up or 11 people showing up, it's a bad idea because you're not going to have enough seats. So here's the setup. This is the probability of no show from the question, and this is the probability of someone showing up, which is 1 minus this. And so in the first event, you would want to do, since you're booking 11, you want only 9 showing up. Sorry, so we want either, so it's a bad idea if everyone shows up, which is a combination of 11, 11. And it's also a bad idea if 1 person doesn't show, so 10 person shows up. It's still a bad idea. But if 9 or less people show up, it's a good idea. So here's the binomial distribution then. Here's the formula. So it's the combination of, again, 11, 11. So this is when everybody shows up, multiplied by, since no one's showing up, everyone is showing up. So this probability to the power 11, because everyone's showing up. So that's the probability, the worst case scenario, every single person shows up. And then the second worst case scenario is 10 people show up and only 1 people doesn't show up. So 10 people show up, so that's the show up probability to the power 10 multiplied by no show up to the power 1, which I don't have to write. And then if you just add these two, so this is the probability that you'll have more than 9 people showing up, which is almost like 70%. That's a really high risk of not having enough seats. So I would say definitely it is not a wise decision, because the probability that not enough seats is, so overbooking is not an unlikely event. Overbooking is very likely, because we found 70% probability. So you would put in that number in this box. Not a wise decision, since it's a high probability, and so on. So here we go, last question. Candy company, 13% of its plain candies are orange, and you have a sample of 200 randomly selected. So finding the mean and the standard deviation. So the mean, so we have 13%, which is 0.13, right? So that was 13%. And our sample is, so that's your P, and your 1 minus P is, not sure if I'm gonna need it. Oh yes, we will. So, and your sample size is, N is 200. So remember, the mean would be N times P. So that would be N times P. That's your mean. And then your standard deviation would be square root of N times P times 1 minus P. So that's the standard deviation formula, which is square root of N times P times 1 minus P. So that's your standard deviation. So put those numbers in the mean and standard deviation box and move on to part B. And in part B, it says, in the random 200 sample, it turns out there's only 8 orange candies. So is this unusual? And so is the claim rate of 13% wrong? So based on the rates, the given 13% rates, we expect to have 26 orange candies, but it turns out there is 8 in reality. So 8 is it far from 26, or is it close enough? How do we know? You look at your standard deviation. So standard deviation is 4.75. So it's a number pretty close to 5. So let's just say it's 5. So 8 is like about 18 points away from the mean. So which is like, 18 points is like more than 3 standard deviations away from the mean. Like almost 3.5 standard, maybe even 4 standard deviation. So it's pretty far from the mean. And because it's really far, we say yes, because 8 is below the minimum usual value. So the minimum, if it's within 2 standard deviations, that would be fine. But it's far below that. So it is unusual, which means that the 13% claimed rate is probably wrong. Alright, so good luck with the quiz. Hope you get much better percentages on your quiz performance.